The Hubble tension is one of the most perplexing puzzles in modern cosmology. Despite decades of study, measurements of the universe's expansion continue to yield different results depending on how they are conducted. Data from the early universe, observed by the Planck satellite, suggest a slower expansion, while measurements from the nearby universe, obtained through Supernovae and Cepheids, indicate a higher rate. This discrepancy could reveal something much larger than simple errors, perhaps new physics, such as an evolution of dark energy or the presence of exotic neutrinos in the early moments of the cosmos. In this video, we will explore why this tension is so crucial and why it continues to fascinate cosmologists around the world. The Hubble tension refers to the discrepancy observed in measurements of the Hubble constant, which indicates the rate at which galaxies are moving away from us. Imagine the universe as a balloon being inflated. As the balloon grows, points on its surface move away from each other. Similarly, galaxies are moving apart as the universe expands, and the Hubble constant allows us to understand how fast this is happening. But what happens when different measurement methods yield different and contradictory results? That is the essence of the Hubble tension. Since Edwin Hubble's discovery in the 1920s, when he identified that galaxies are moving away from us, there has been an effort to establish a clear relationship between their recession speed and their distance. Hubble not only observed that galaxies were moving, but he found that the farther away they were, the faster they were receding. However, over the years, scientists have used various techniques to measure this constant. And this is where complications arise. Some methods, such as those involving supernovae, use stellar explosions to measure distances in the universe. Others, like the parallax of Cepheids, rely on observing pulsating stars whose luminosity varies predictably. In theory, these methods should provide a coherent and unified result, but reality has proven to be more complex. The figures do not add up, leading the scientific community to question, what are we overlooking? The discrepancy in the measurements of the Hubble constant could be more than just a simple experimental error. Perhaps behind these differences lies new physics that we have yet to discover. Could it be that our current understanding of the universe is incomplete? This question has led many to explore the role of dark energy, a mysterious force that seems to be accelerating the expansion of the universe. Dark energy is a key component that could explain why galaxies are moving away faster than we expected. Imagine you are on a high-speed train and watching trees along the tracks pass by quickly. If the train unexpectedly accelerates, the trees would appear to move away even faster. Dark energy acts similarly in the vast landscape of the universe, accelerating expansion and further complicating our measurements of the Hubble constant. As we delve into the cosmological models that have emerged to explain the structure and evolution of the universe, it is crucial to understand how they fit with current observations. These models, which include the Big Bang theory and cosmic inflation, have provided a solid foundation for our understanding of the cosmos. However, the Hubble tension raises questions about the validity of these models. Could adjustments to our theories be necessary to reconcile the differences in measurements? Dark matter, another fundamental component of our understanding of the universe, also plays an important role in this story. Imagine dark matter as a conductor coordinating the movement of galaxies. Without it, the dynamics of the universe would be chaotic and disorganized. But how does this influence the Hubble tension? Could dark matter be affecting the measurements of the Hubble constant in ways we have not yet fully understood? Observations of the cosmic microwave background, which is the echo of the Big Bang, have provided valuable data on the expansion of the universe. These measurements have helped scientists establish a map of the cosmos. But even here, the Hubble tension is present. The discrepancy between what we observe through the cosmic background and what we measure today is a puzzle that needs to be solved. As we advance into the era of modern astronomy, Technological advancements have drastically changed the way we measure the expansion of the universe. More powerful telescopes and more precise observation techniques have allowed us to see further and in greater detail. However, the Hubble tension remains a persistent challenge. Could these new instruments provide answers to questions that have plagued astronomers for generations? The implications of this tension go beyond simple measurements. They delve into the heart of fundamental physics. What do the discrepancies in the Hubble constant mean for our laws of physics? Are we on the brink of a new paradigm that will change our understanding of how the universe works? Reflecting on this, what does the Hubble tension really mean for us as human beings? It is not just about numbers and formulas. It is about our place in the cosmos, our innate curiosity, and the quest for answers. The Hubble tension invites us to question, to explore, and to marvel at the vast possibilities of the universe around us. The search for answers about the Hubble tension does not stop. Scientists around the world are collaborating, debating, and conducting innovative research to unravel this mystery. The scientific community is at a turning point, and each discovery brings us a little closer to understanding what is really happening in the universe. Finally, it is essential that science is communicated effectively to the general public. The popularization of science is crucial for everyone to understand complex topics like the Hubble tension. Each of us has a role in this story, as it is about better understanding the universe and our place in it. Are we ready to continue exploring? The answer is undoubtedly a resounding yes. The Hubble constant is like the stopwatch of the universe, an indicator that reveals the speed at which it expands. But where does this fascinating figure come from, and what is its history? Traveling back to the 1920s will take us to the discovery of Edwin Hubble, an astronomer whose name became synonymous with the expansion of the cosmos. Before Hubble, most scientists believed that the universe was static, almost like a vast ocean of stars that did not move. But Hubble shattered that notion, and in doing so, changed our view of the universe forever. The story begins in 1924, when Hubble first observed the galaxies closest to us. Using the Mount Wilson telescope, Hubble identified that some of these galaxies were moving away from us at astonishing speeds. How did he come to that conclusion? By studying the light emitted by these galaxies, he realized that their light was redshifted, a phenomenon known as redshift. This effect occurs when an object moves away, similar to how the sound of a siren becomes higher as it approaches and lower as it moves away. Hubble used this observation to establish a relationship between the recession velocity of galaxies and their distance from us. Imagine throwing a stone into the water and watching the waves that form. The farther you throw the stone, the faster the waves move away from the shore. Hubble applied this same idea to the universe. The farther a galaxy is, the faster it is receding from us. With this relationship, he was able to calculate a constant, now known as the Hubble constant. This was a significant breakthrough, as it provided a way to measure the expansion of the universe. A revolutionary concept at that time. But why is this constant so important? The Hubble constant not only tells us that the universe is expanding, but it also implies that it has an origin, an initial explosion that we all know as the Big Bang. This discovery was a milestone that laid the foundations of modern cosmology, allowing scientists to explore the past of the universe while simultaneously projecting its future. However, the story doesn't end here. As astronomers began to work with more data and refine their methods, new questions arose. How can we accurately measure this constant? What techniques would we use to obtain reliable results? In the search for answers, several methods were developed to measure the Hubble constant, among them the use of supernovae, stellar explosions that shine with incredible intensity, and the parallax of Cepheid variables, stars that vary their brightness in a predictable manner. Stand out. Supernovae are like beacons in the vast ocean of the universe. When astronomers observe a supernova, they can calculate its true brightness and compare it to its apparent brightness. If the supernova appears dimmer than it should, that means it is farther away, and thus its recession velocity can be determined. On the other hand, Cepheid variables are pulsating stars that, by varying their brightness, indicate their distance. By combining these techniques, scientists have been able to calculate the Hubble constant with a certain degree of accuracy. However, as science progressed, intriguing discrepancies in the measurements emerged. Some methods yielded results that differed significantly from others. How is it possible for two distinct techniques to arrive at such different figures? This discrepancy has become a mystery that has captivated the scientific community. While some methods suggest that the universe is expanding faster than previously thought, others suggest a slower rate. What is really happening? The Hubble tension leads us to a crucial point where cosmology finds itself at a crossroads. This discrepancy is not just a mathematical problem. It raises fundamental questions about the nature of the universe. As astronomers attempt to resolve these differences, they face the complexity of concepts like dark energy, a mysterious force that seems to be accelerating the expansion of the universe. The story of the Hubble constant shows us how a simple discovery can open the door to countless questions. Since its discovery, we have learned that the cosmos is a dynamic place full of surprises and mysteries to unravel. Each measurement, each observation is another step toward understanding the vast and complex web that constitutes our universe. The search for the truth behind the Hubble constant is a journey that continues, a journey that involves the collaboration of scientists from around the world in an effort to unravel the secrets of the cosmos. What else will this search reveal? The answer could change our understanding of the universe forever. The Hubble constant is a key number in cosmology, but how did we come to measure it? The answer to this question is fascinating and takes us on a journey through the vast universe. Imagine you are at a music concert. The lights go out, and in the darkness you hear the sound of the music. Now, if the music starts to play louder, how do you know where it's coming from? The answer lies in the way sound travels through the air. And that is exactly what astronomers do when they try to understand how galaxies are expanding. The methods for measuring the Hubble constant have evolved over the years. For example, one of the most prominent methods involves supernovae, those bright stellar explosions that can light up the sky. Why are they so important? Supernovae, in their brightest phase, can be seen from great distances and act as beacons in the darkness of the universe. When we measure the light they emit, we can calculate how far away they are. By combining this information with the speed at which they are moving away from us, we get a clear picture of the expansion of the universe. Another method used to measure the Hubble constant is the parallax of Cepheids. Cepheids are stars that pulsate, increasing and decreasing their brightness in regular cycles, like a rotating lighthouse. Their light can be measured to determine their distance. But how do we know how far away they are? The key lies in the time it takes for them to shine at their full brightness and in the pattern of their brightness. By understanding these stars, astronomers become capable of calculating cosmic distances with surprising accuracy. Now let's talk about the relationship between the recession velocity and the distance of galaxies. When we look up at the sky, every bright point we see is a galaxy, and many of them are moving away from us. This is due to the expansion of the universe. Have you ever seen a balloon inflate? As the balloon expands, the points drawn on its surface move away from each other. In this case, the galaxies are those points, and the balloon is the universe. The farther away a galaxy is, the faster it is moving away. This relationship is known as Hubble's law. However, it's not all that simple. Despite having different methods, the results regarding the Hubble constant have shown discrepancies. Some studies suggest that the universe is expanding faster than previously estimated, This tension has led to a debate among astronomers. Why are there differences in the measurements? Could it be that some methods are not as accurate as once thought? Or perhaps there is something bigger at play that we do not yet understand. For example, what if dark energy, that mysterious force that seems to be accelerating the expansion of the universe, plays a more significant role than we think? Dark energy is like an engine driving the growth of the universe, but its nature is still an enigma. As we investigate further, we realize that this force could be influencing the Hubble constant, altering our measurements. The use of advanced telescopes has allowed scientists to obtain more precise data about the Hubble constant. Observations from the Hubble Space Telescope and other instruments have made measurements that challenge previous knowledge. However, even with the most advanced technology, discrepancies still exist. This raises the question, are these differences signaling something fundamental about our understanding of the cosmos? The importance of measuring the Hubble constant goes beyond a simple number. What does it really mean for us? This value helps us understand the history of the universe, its size and its future. Being able to determine how fast the universe is expanding is crucial for knowing how it will behave over the next billions of years. The answers to these questions could change our perception of our place in the vast cosmos. At its core, the Hubble constant is not just a number, it is a reflection of the history of the universe, every galaxy we observe. Every supernova we measure tells us a part of that story. What if those narratives are not entirely coherent? The discrepancies in measurements could be signals that there is more to discover, a new chapter waiting to be written in our understanding of the universe. As scientists continue their work, each new discovery can add another piece to the puzzle. What new techniques might emerge? What other observations could revolutionize our understanding of the Hubble constant and the expansion of the universe? The quest for answers is an exciting journey full of surprises. And so, as we look toward the cosmos, we encounter questions that challenge us to keep exploring. The Hubble constant is just one part of a much larger puzzle. The more we investigate, the more we realize that the universe is a place full of mysteries to solve, and each answer leads us to new questions. Science advances, and with it, our understanding of the vast and magnificent universe we inhabit. The Hubble tension has sparked the interest of many scientists, but why are there differences in the measurements of this constant so fundamental to understanding the universe? To address this question, it is first essential to understand how the Hubble constant has been measured over time. The current discrepancies are not simply calculation errors. They reflect the complexity of the cosmos and the varied techniques used to measure the expansion of the universe. The first notable technique is the use of supernovae, which are bright stellar explosions that occur when a massive star exhausts its fuel. These explosions are so luminous that they can be seen at incredible distances, even from the farthest reaches of the universe. Astronomers have learned to use these supernovae as beacons to determine the distance to galaxies. By knowing the intrinsic luminosity of a supernova and comparing it to its apparent brightness from Earth, one can calculate how far the light has traveled and, therefore, the distance to it. However, this method has its limitations, as not all supernovae are the same, and variations in their luminosity can introduce uncertainties. On the other hand, the Cepheid method has been fundamental in the history of cosmology. Cepheids are stars that vary their brightness in a regular manner. By studying a Cepheid, astronomers can determine its pulsation period and, from that, calculate its luminosity. Again, by comparing this intrinsic brightness with the observed brightness, one can calculate the distance. However, the difficulty lies in the fact that Cepheids are not found everywhere, and their study can be complicated in more distant regions of the universe or those with significant light interference. As research has progressed, other methods have been developed, such as parallax. which involves observing an object from different positions on Earth as it orbits the Sun. This method is particularly useful for measuring distances to stars within our galaxy, but it becomes less effective at larger scales. As we move further away, stars become more difficult to observe, and parallax becomes a limited technique. Discrepancies in the measurements of the Hubble constant become evident when we compare results obtained through different methods. For example, some recent studies based on supernovae report a Hubble constant significantly higher than estimates based on the cosmic microwave background. The latter method, which observes the residual radiation from the Big Bang, suggests a lower value. How is it possible that two such different techniques produce such divergent results? The scientific community has reacted to these results with a mix of surprise and curiosity. Some researchers have begun to question theories that were previously considered solid. Could it be that there is something fundamentally wrong with our understanding of the expansion of the universe? Or perhaps we are witnessing the manifestation of new phenomena that we have not yet fully understood. The Hubble tension, then, not only represents a challenge, but also an opportunity to deepen our knowledge of the cosmos. One possible explanation for these discrepancies could be related to dark energy, that mysterious force that seems to be accelerating the expansion of the universe. If dark energy acts differently at different scales of the universe, that could influence the measurements. However, this is just one hypothesis among many, and the scientific community is actively searching for answers that can help resolve this enigma. The Hubble tension is not just a scientific puzzle, it also raises profound philosophical questions about our understanding of the universe. If measurements are affected by factors we have not considered, what other truths are eluding us? This kind of questioning is what makes cosmology so fascinating. Each discovery leads to more questions, and each answer can open a new avenue of research. Collaboration among scientists from various disciplines has also been key in the search for answers. Astronomers, theoretical physicists, and technology experts work together to analyze data and propose new experiments. This interaction not only enriches knowledge, but also fosters a spirit of shared curiosity. The Hubble tension has created a dialogue between different fields of knowledge that might otherwise have remained isolated. As we enter the era of modern astronomy, technological advances have improved our observational capabilities. More powerful telescopes and more sophisticated data analysis techniques are changing the way we measure the expansion of the universe. However, even as technology advances, the interpretation of data remains a challenge. To what extent can technology resolve the discrepancies we face? The answer to the Hubble tension may not be straightforward. It could require a multidisciplinary approach and a re-evaluation of our fundamental theories about the physics of the cosmos. The history of science is full of moments when a discrepancy led to a radical change in our understanding. Perhaps this is a similar opportunity to rethink what we believe we know about the universe. The Hubble tension invites us to reflect on the very nature of knowledge. In a world where we seek certainties, science often confronts us with uncertainty, and while this can be uncomfortable, it is also a reminder that the path of discovery is, by nature, a journey full of surprises. The exploration of the cosmos is exciting precisely because it confronts us with the unexpected. As we continue to investigate, the Hubble tension will remain a hot topic. Future observations and advancements in technology will likely provide us with more clues about this mystery. Science is a constantly evolving endeavor, and each small discovery can be a stepping stone toward a deeper understanding of the universe we inhabit. In this sense, the Hubble tension is not only a challenge but also an invitation to all of us. It invites us to question, to investigate, and to marvel at the vastness of the cosmos. And with each question we ask, we get a little closer to unraveling the secrets of the universe. Dark energy is one of the great mysteries of the universe. But what is it really? To understand it, we must first imagine the universe as a balloon. When we inflate a balloon, the surface expands and the marks on it move away from each other. This is a good model to visualize how galaxies are moving away from each other as the universe expands. However, there is an additional component that makes this expansion even more intriguing: dark energy. Dark energy is like a mysterious force that accelerates the expansion of the universe. But why is it so crucial to the Hubble tension? The Hubble tension refers to the discrepancies in the measurements of the Hubble constant, which is the rate at which galaxies are moving away from us in relation to their distance. If dark energy is accelerating this expansion, shouldn't it affect how we measure that speed? When Edwin Hubble conducted his early experiments, he assumed that the universe was expanding at a constant rate. However, more recent studies suggest that dark energy is causing that expansion to accelerate. This means that instead of a simple straight-line race, galaxies are in a kind of race where suddenly some are running much faster than others. This creates a dilemma for astronomers trying to calculate the Hubble constant. We could imagine dark energy as a driver in a car race. At first, all the cars have their speed, but suddenly the driver decides to hit the accelerator. The cars that were previously at a similar distance start to separate quickly. This is what is happening in the universe. Dark energy acts like that accelerator, and the discrepancies in the measurements of the Hubble constant could reflect how different techniques respond to this acceleration. So how does all this relate to the expansion of the universe? Dark energy represents about 70% of the total energy of the cosmos. This means that most of the universe is driving its own expansion. However, this dark energy cannot be observed directly. We have been forced to infer its existence from its effects on the movement of galaxies and on the cosmic microwave background. Reflecting on this, an intriguing question arises: what if dark energy is not constant? Some scientists are exploring the idea that dark energy could change over time. This could have a profound impact on how we understand the Hubble constant. If dark energy has variable behavior, our current measurements might not be accurate. Moreover, dark energy also raises questions about the ultimate fate of the universe. If the expansion continues to accelerate, we could face a future where galaxies move so far away that they become invisible to each other. This scenario, known as the Big Freeze, suggests that over time the universe could become a dark and empty place. But is it really that simple? As scientists delve deeper into the study of dark energy, they are beginning to discover that it is not a straightforward phenomenon to understand. There are various theories attempting to explain its nature. Some suggest that dark energy could be a property of empty space, while others propose that it might be a new type of physical field that we have yet to fully comprehend. What is fascinating about dark energy is that it is challenging our most fundamental ideas about the universe. As we continue to investigate, we are confronted with questions that go beyond physics and cosmology. What does it mean for us as human beings to live in an expanding and accelerating universe? How do we fit into this vast and mysterious cosmos? In this sense, dark energy is not just an abstract concept. It has profound implications for our understanding of the universe and our place in it. Each discovery about dark energy brings us closer to unraveling the secrets of the cosmos. However, there is still much to learn and explore. With each new measurement and observation, scientists hope that dark energy will reveal more of its secrets. Could we someday understand its nature and how it influences the Hubble constant? The answer to this question could radically change our view of the universe. The search for answers continues, along with the hope that one day we can comprehend this cosmic enigma known as dark energy. The Hubble tension, therefore, is not just a mathematical puzzle. It is a reflection of the complexities of the universe, of the forces that shape it, and of the mysterious energies that drive it. Dark energy is one of the keys to understanding how the universe works. And as we advance in our research, each discovery brings us one step closer to uncovering the truth. Have you ever thought about how scientists try to understand the vast universe that surrounds us? One of the most powerful tools in this quest is cosmology, which helps us unravel the secrets of the cosmos. In this section, we will address cosmological models, those theoretical frameworks that allow us to understand how the universe behaves. But what exactly are these models, and why are they so crucial for our understanding of space-time? To begin with, cosmological models are like maps that guide us through the vast ocean of the universe. Imagine you are sailing on a boat in the middle of the immensity of the sea. Without a map, you could easily get lost. Similarly, cosmological models provide us with a representation of how the universe is organized, from its origin to its possible fate. But how are these models constructed? Cosmologists use a combination of physical theories, astronomical observations, and mathematics to create these models. For example, the most accepted model today is the Big Bang model, which suggests that the universe began about 13.8 billion years ago from an extremely hot and dense singularity. But what does this imply for the expansion of the universe, and in particular for the Hubble constant? The Hubble constant is essential in these models as it describes the rate at which galaxies are moving away from us. If we visualize the universe as a balloon that is inflating, the Hubble constant would be the measure of how fast that balloon is expanding. The farther away a galaxy is, the faster it is moving away from us. But why is it so important to know this speed? Understanding the expansion of the universe through the Hubble constant allows us to calculate distances and times. Thus, cosmologists can estimate not only how much the universe has expanded, but also when the Big Bang occurred. However, cosmological models also face challenges. As we make new observations, we discover that some of our initial assumptions may not be entirely correct. What happens when observations do not fit the established model? That is the key to science: constant revision. When the data does not fit, scientists must rethink their models. For example, the discrepancy in measurements of the Hubble constant has led cosmologists to explore new ideas and theories. But what happens when existing models are no longer sufficient? This is where more advanced concepts come into play. Some scientists are working on models that incorporate factors such as dark energy and dark matter, two components that seem to play a fundamental role in the dynamics of the universe. Dark energy, which is believed to constitute about 70% of the universe, is driving the acceleration of the expansion. How does this fit into our current models? Moreover, cosmological models are not just static descriptions. They are dynamic and evolve as we gather more information. For example, advancements in observing the cosmic microwave background have provided crucial data that have helped refine and adjust these models. But how do we know that these models are correct? The validation of a cosmological model is based on its ability to predict observable phenomena. If a model can accurately predict what we observe in the universe, its credibility is strengthened. However, discrepancies in the Hubble constant have led many to question whether the current model, which is based on Einstein's general relativity, is the right one. Are we in search of a new theory to replace what we thought we knew? The scientific community is filled with passionate debates about which direction research should take. Some cosmologists are exploring alternative theories, while others defend current models. These discussions are fundamental, as each new perspective can offer clues about the nature of the universe. But what does this mean for us as curious observers of the cosmos? The quest for answers about the expansion of the universe and the Hubble tension is not just a scientific exercise. It is also a philosophical exploration. As we formulate questions about our place in the universe, we confront profound issues about existence itself. Are we alone in this vast expanse? How does our brief existence relate to the history of a cosmos that is constantly expanding and evolving? In the end, cosmological models are more than just equations on a blackboard. They are a representation of our curiosity and our desire to understand the universe. As we continue to explore and adjust these models, each discovery brings us a little closer to the answers we seek. Cosmology is ultimately a journey of discovery, and each new finding propels us forward in our quest for cosmic truth. How far will this journey take us? Only time will tell. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. Dark matter, that intriguing component of the universe that we cannot see, plays a crucial role in the dynamics of the cosmos, and its relationship with the Hubble tension is a fascinating topic. What exactly is dark matter, and why is it so important for understanding how the universe expands? To start, imagine you are in a park on a sunny day. You can see people playing, trees swaying in the wind, and birds flying. However, there is something you cannot see, the air, even though you do not perceive it. It is there, influencing everything that happens around you. This is how dark matter functions in the universe. Dark matter makes up about 25% of the total mass and energy of the universe. Unlike ordinary matter, which forms stars, planets, and ourselves, dark matter does not emit, absorb, or reflect light, making it a true cosmic enigma. But how do we know it exists? Scientists have deduced its presence from the gravitational effects it exerts on visible matter. For example, if we observe a rotating galaxy, we can notice that the stars on its periphery move at much higher speeds than would be expected if we only consider visible matter. Why does this happen? The answer lies in dark matter, which acts as an invisible glue, holding galaxies together and preventing them from collapsing. And how does this relate to the Hubble tension? To understand this, we must first remember that the Hubble constant is related to the rate at which the universe expands. If dark matter plays such a significant role in the structure and development of the cosmos, then its influence on expansion is undeniable. But what happens if the estimates of the amount of dark matter are not accurate? That could be one of the reasons why measurements of the Hubble constant are showing discrepancies. Let's think of a practical example. Imagine you are trying to measure the length of a string using a ruler. If the ruler has an incorrect mark, your measurements will not match, and that could lead you to think that the string is shorter or longer than it actually is. Similarly, if dark matter models are not accurate, estimates of the universe's expansion could also be wrong. This is what concerns cosmologists, because every time new observations are made, it seems that the Hubble tension becomes more evident. Dark matter is not just an abstract concept. It has practical implications for how we understand the universe. Current cosmological models rely heavily on it, and any change in our understanding of dark matter could trigger a domino effect in our theories about how the universe is expanding. But what if we discover that dark matter is not what we think? This could open the door to new theories and new ways of viewing the physics of the cosmos. An interesting aspect is that although we cannot see dark matter, we can detect it indirectly. This is done through what is called gravitational lensing, when the light from a distant galaxy passes near a massive object, such as a galaxy cluster containing dark matter. The light bends. By analyzing that curvature, scientists can infer the amount and distribution of dark matter in the cluster. But what would happen if the properties of dark matter change over time? That could further complicate our measurements of the Hubble constant. In this sense, we can see that dark matter can be both an ally and an adversary in our quest to understand the universe. While it helps us explain many things, it can also be the cause of confusion and discrepancies. The Hubble tension, in this context, becomes a puzzle that scientists must solve. Could it be that dark matter not only influences the rate of expansion, but is also at the center of the discrepancy we are observing? Current theories suggest that dark matter is cold and does not interact with light, but there are alternative proposals suggesting that there could be more exotic forms of dark matter. What if dark matter is not just one type, but a combination of several? These are the kinds of questions cosmologists are trying to answer, and each answer could lead us to a new level of understanding about the nature of the universe. The study of dark matter and its relationship with the Hubble tension is not just a field of scientific research, but also an area of philosophical reflection. It leads us to question our understanding of reality and what we consider visible. In a universe full of mysteries, dark matter reminds us that there are many things we still do not know and that our theories could be subject to radical changes. The search for answers about dark matter and its relationship with the Hubble tension is an exciting journey. As technology advances and new observational methods are developed, we can expect new ideas and discoveries to emerge. So, as we continue to explore the cosmos, let us not forget that what we do not see may be just as important as what we do see. In summary, dark matter is not just a component of the universe. It is a key element in understanding the Hubble tension and, therefore, the expansion of the universe. Every new discovery in this area could redefine what we know about cosmology and our place in the cosmos. Science, after all, is a path full of surprises, and dark matter is just one of the many surprises that await us in the vast and mysterious universe. The expansion of the universe is a fascinating phenomenon, and one of the keys to understanding it is the observations of the cosmic microwave background. But what exactly is this cosmic background, and why is it so crucial for our understanding of the Hubble constant? To answer this, let's go back in time, right after the Big Bang. At that time, the universe was extremely hot and dense. Over time, it began to expand and cool. When it reached a sufficiently low temperature, about 300,000 years after the Big Bang, protons and electrons combined to form hydrogen atoms. This moment marked the beginning of the recombination era, a milestone that allowed light to begin traveling freely. That light, which was once a brilliant torrent, has been cooling as the universe expands. Today, we can detect it as a background radiation that fills the entire cosmos. This radiation is known as the cosmic microwave background and is an echo of the early universe. Imagine a gentle murmur of light that speaks to us about the first moments of the universe's existence. But how can we use this information to better understand the Hubble constant through various observations? Scientists have been able to map this radiation and analyze its characteristics. One of the most significant discoveries was that this radiation is nearly uniform in all directions, suggesting that the universe is homogeneous on a large scale. However, there are also small variations in the temperature of the cosmic background. These variations are fundamental as they provide clues about the distribution of matter and energy in the universe. But how does this relate to the Hubble constant? The answer lies in that these fluctuations allow us to estimate the density of the universe and how it has changed over time. Through cosmological models, we can infer how the expansion of the universe has evolved. In this context, the Hubble constant appears as a key parameter that describes the rate of expansion of the universe at a given moment. It is like the speedometer of a car that tells us how fast we are moving in the vast cosmic space. Now, what happens if the measurements of the cosmic microwave background do not match the observations from other techniques? This is one of the great mysteries of the Hubble tension. On one hand, we have data from cosmic radiation, suggesting that the universe is expanding at a certain rate. But on the other hand, observations of supernovae and other galaxies indicate a different rate of expansion. This raises an intriguing question. What is the universe trying to tell us with this discrepancy? Scientists have used satellites, such as Planck, to measure the cosmic microwave background with great precision. These measurements have provided a value for the Hubble constant that, although surprisingly low, is consistent with the standard model of cosmology. However, when compared to direct measurements made through the observation of supernovae, we find a notable difference. This leads us to question whether there is something we do not fully understand about the expansion of the universe. The key to resolving these discrepancies may lie in the properties of dark energy, that mysterious force that seems to be accelerating the expansion of the universe. But is it possible that the cosmic microwave background and dark energy are in a cosmic tug-of-war? The answer might be that these two influences are interrelated, and understanding how they behave together is essential to unraveling the Hubble tension. Through observations of the cosmic background, we have also learned about dark matter. This invisible form of matter, which does not emit light, is fundamental to the formation of structures in the universe. The fluctuations in the cosmic background not only speak to us about dark energy, but also about how dark matter has influenced the evolution of the universe. What if the relationship between dark matter and dark energy plays a crucial role in resolving the tension? The modern era of astronomy is revolutionizing our understanding of the cosmos. Thanks to technological advancements, we can now observe the cosmic microwave background with unprecedented precision. This data is allowing us to refine our models and theories about how the universe works. But at the same time, each new discovery seems to open more questions than answers. Could it be that we are on the brink of a paradigm shift in cosmology? At the end of the day, the quest to understand the cosmic microwave background and its relationship with the Hubble constant pushes us to redefine our understanding of the universe and its history. Each small discovery is like a piece of a cosmic puzzle that, although it sometimes seems to fit strangely, offers us a clearer view of who we are and where we come from. The Hubble tension, then, is not just a set of numbers. It is an invitation to delve into the mysteries of the cosmos and our own existence within it. So, as we continue to explore, let us remember that every question that arises brings us one step closer to the truth. Science is a journey, and the cosmic microwave background is one of the many stops on this exciting path toward understanding the universe. What new revelations await us on the horizon? Only time and research will tell. The era of modern astronomy has been marked by an extraordinary advance in our capabilities to explore the cosmos. Have you ever wondered how we have come to understand the universe in the way we do today? The answer lies in the combination of human ingenuity and cutting-edge technology, from telescopes that can observe unimaginable distances to satellites that measure cosmic radiation. Each of these advancements has played a crucial role in how we study the expansion of the universe and, therefore, the Hubble constant. One of the most fascinating tools we have developed is the Hubble Space Telescope, which has provided images and data that have revolutionized our understanding of the cosmos. This telescope, which orbits the Earth, has allowed astronomers to observe galaxies that are billions of light years away. But what difference does this make in measuring the Hubble constant? By observing these distant objects, we can measure their recession speed, that is, how fast they are moving away from us, and this is fundamental for calculating the expansion of the universe. Technology does not stop there. With the development of next-generation telescopes, such as the James Webb Space Telescope, we have been able to look beyond what Hubble offered us. This new observatory is like having a window into the past, as it can capture the light from the first stars and galaxies that formed after the Big Bang. Can you imagine being able to see what happened billions of years ago? This view of the past not only helps us understand how the universe formed, but also provides valuable information about the Hubble constant and its tension. Modern astrophysics has also benefited from the use of artificial intelligence. Advanced algorithms can analyze immense amounts of data in seconds, something that would be impossible for a human. This has allowed scientists to identify patterns and correlations in galaxy observations that previously went unnoticed. Artificial intelligence is helping to unravel the mysteries of the universe, including the resolution of the Hubble tension. Moreover, international collaboration has been fundamental in this new era of astronomy. When scientists from different parts of the world combine their knowledge and resources, the results are astonishing. Imagine a group of astronomers from North America, Europe, and Asia working together to gather data on supernovae and Cepheids. This collaboration not only expands the database but also improves the accuracy of measurements of the Hubble constant. Advances in telescope technology have also allowed astronomers to observe phenomena that were previously invisible. For example, gravitational waves, which are a manifestation of the movement of extremely massive objects, such as two colliding black holes. These waves, first detected in 2015, open a new window for observing the universe and may provide clues about the expansion and the Hubble tension. Who would have thought that the sound of the universe could be so revealing? Satellites measuring the cosmic microwave background have been another milestone. This type of radiation is like an echo of the Big Bang and offers us information about the large-scale structure of the universe. The data obtained from these measurements have been essential for calibrating our estimates of the Hubble constant. By studying these traces of the past, scientists can gain a better understanding of how the universe has evolved. But what about computer simulations? These tools have become essential in modern cosmology. Through advanced simulations, scientists can model different scenarios about the expansion of the universe and compare those scenarios with observed data. This not only helps verify existing theories, but also allows for the exploration of new ideas about the Hubble tension and its possible resolution. Technological advances have not only improved our ability to observe, but also our ability to communicate discoveries. Digital platforms and social media have allowed scientific findings to reach a broader audience. This is crucial, as science does not only belong to scientists, but is a heritage of all humanity. The popularization of science helps spark interest in cosmology and fosters a culture of curiosity and learning. In this context of technological advances, each new discovery seems to open the door to more questions. Are we close to resolving the Hubble tension? What will the next advancements in technology tell us? The answers to these questions could redefine not only our understanding of the universe, but also our place in it. As we look to the future, modern astronomy faces new challenges and opportunities. The arrival of more powerful telescopes and the development of new measurement methodologies promise to provide answers to the questions that still haunt us. However, science is always a path filled with uncertainty, and each answer generates new questions. The era of modern astronomy has taught us that, although we have made significant progress, the universe still keeps its secrets. The Hubble constant and its tension are just a part of the cosmic puzzle we continue to try to solve. The search for answers unites us as humanity, as we all share the same curiosity about the unknown. Astronomy is not just a field of study, it is a constant adventure into the unknown, and as we continue to explore, each technological advance brings us a little closer to understanding the vastness of the cosmos and our innate curiosity about it. So, as we move forward, let us remember that every star we see in the sky is a reminder of how far we have come and how far we can still go. What does the Hubble tension really mean for fundamental physics? This concept, which has captured the attention of astronomers and physicists alike, not only raises questions about the expansion of the universe, but also challenges our deepest notions about the laws that govern it. To understand this, we must first delve into the intersection between cosmology and theoretical physics. The Hubble tension refers to the discrepancy in measurements of the Hubble constant, which tells us how fast the universe is expanding. But why is this constant important? Imagine the universe as a huge balloon that is constantly inflating. The speed at which points on the surface of the balloon expand is what the Hubble constant tries to describe. However, when different methods attempt to measure that speed, they yield different results. This variability leads us to question whether there is something deeper at play. When we observe the expansion of the universe, we also confront the very nature of time and space. According to Einstein's theory of relativity, time and space are intrinsically connected, forming a fabric that curves and distorts with the presence of mass and energy. So, what does this mean for the Hubble tension? It invites us to reconsider how time and the expansion of the universe are related. Is it possible that our current understanding is incomplete? On the other hand, the Hubble tension might suggest that the laws of physics as we know them may need adjustments. Think of a clock that does not keep time as expected. If time is not measured in the conventional way, what other aspects of reality might also be distorted? The Hubble tension could be a signal that there is more to discover in the universe. Moreover, this phenomenon could be linked to dark energy, that mysterious force that seems to be driving the acceleration of the universe's expansion. If dark energy plays a crucial role in the Hubble tension, then our theories about gravity and the dynamics of the universe must be revised. What implications would this have for our understanding of matter and energy? It leads us to question whether there are fundamental forces that we have yet to identify. The interaction between dark energy and the Hubble tension also raises questions about the nature of reality. If the universe is expanding at an accelerated rate, what does that mean for the future of the cosmos? Are we, in some way, in a universe that behaves differently from what our current theories predict? The Hubble tension not only challenges our measurements, but also our view of the universe as a whole. A fascinating aspect is how the Hubble tension may be related to dark matter, that invisible substance we cannot directly detect but know is there due to its gravitational effects. If dark matter plays a role in the expansion of the universe, how do these two forces intertwine in the fabric of the cosmos? The possibility that unknown interactions exist between these entities opens a range of possibilities for scientific investigation. The search for answers regarding the Hubble tension also translates into new opportunities for fundamental physics. As scientists strive to understand and reconcile the discrepancies in measurements, they are driven to develop more robust and unified theories. Could it be that we are on the brink of a new paradigm in physics? Every investigation conducted, every observation made, brings us closer to unraveling the mysteries of the universe. What is at stake is nothing less than our understanding of the laws of nature. If measurements of the Hubble constant remain contradictory, we could be facing a crisis in cosmology. However, in every crisis, there is an opportunity. The Hubble tension could be the key to opening new doors in our understanding of the cosmos, pushing us toward more complex and fascinating theories. The philosophical implications are equally profound. The Hubble tension not only leads us to question our scientific theories, but also invites us to reflect on our place in the universe. Are we truly understanding what it means to exist in a constantly expanding cosmos? The quest for truth in science compels us to reconsider our most fundamental beliefs. Every discovery in this realm is not only a step forward in science, but also a reminder of the humility needed in the face of the vastness of the universe. The Hubble tension is a call to curiosity, exploration, and the ongoing pursuit of knowledge. Every question that arises brings us a little closer to the essence of reality. In this journey toward understanding, it is essential to remember that science is a constantly evolving process. With each technological advance and each new observation, the pieces of the puzzle are fitting together. While the Hubble tension represents a challenge, It also symbolizes the beauty and complexity of the universe, a place full of mysteries yet to be explored. At the end of the day, the Hubble tension teaches us that, in the pursuit of knowledge, we should never take anything for granted. With each new finding, each new question, we expand our vision of the cosmos and draw closer to unveiling the secrets that surround us. Science, in its essence, is a continuous journey, and the Hubble tension is just one of many stops along that vast path. The relationship between relativity and the expansion of the universe is a fascinating enigma that leads us to question how we understand reality. When we talk about the Hubble tension, it is essential to consider how Einstein's theory of relativity forms the basis of our understanding of the cosmos. But how can a theory formulated in the early 20th century carry so much weight in our modern observations? Relativity, in simple terms, tells us that space and time are like a fabric that can be stretched and curved. Imagine you are on a huge trampoline. If you place a marble in the center, it will sink, creating a slight depression. Now, if you put a bowling ball, the curve of the fabric deepens even more. This model helps us visualize how gravity is not just a force that attracts objects, but also affects the way we experience time and space. Einstein proposed that gravity affects the trajectory of light. So, if a galaxy is moving away from us, its light shifts toward the red as if it were stretching a rope. This phenomenon, known as redshift, is one of the keys to understanding the expansion of the universe and therefore the Hubble constant. But what role does relativity play in this process when we observe how galaxies behave? Relativity indicates that the expansion of the universe is not uniform. Instead of being like a balloon that inflates evenly, it is more like a birthday cake where the cherries move apart as the cake bakes. Different regions of the universe can expand at different rates, leading us to the discrepancy we observe in the Hubble constant. Does this mean that our understanding of gravity needs to be revised? Relativity offers us a framework to understand how dark energy, that mysterious force driving the accelerated expansion of the universe, interacts with gravity. According to Einstein, energy and mass are interchangeable, suggesting that dark energy, being a form of energy, could be influencing the very structure of space-time. This raises an intriguing question. Could dark energy be the key to resolving the Hubble tension? The expansion of the universe, as described by relativity, also leads us to reflect on the ultimate fate of the cosmos. Are we in a universe that will continue to expand forever, or will it eventually be pulled back by gravity? Relativity opens the door to many possibilities, including the idea that the universe could end in a big crunch, where everything collapses into a single point. However, relativity is not without its challenges. As scientists attempt to reconcile quantum theory and relativity, questions arise about the very nature of gravity. Is it a fundamental force or merely a manifestation of the geometry of space-time? This dilemma leads us to explore new dimensions in physics. When cosmologists study the Hubble tension, they must consider how relativity affects their measurements. The way distance to galaxies is measured, as well as the speed at which they are receding, can be influenced by the curvature of space-time. This means that in seeking answers, scientists must deal with a complex puzzle where each piece can change our perception of the universe. If relativity is the key to understanding the expansion of the universe, what role do observations play in all of this? Each new discovery, each new measurement is like a new clue in an investigation. Telescopes looking at the stars not only show us the past, but also offer glimpses of the future. The Hubble tension, then, becomes a mystery that pushes us to go beyond the known. The theory of relativity also invites us to think about the nature of time. If space and time are intertwined, what does this mean for our perception of the history of the universe? Can we truly comprehend the vast expanse of cosmic time, or are we limited by our human experience? Reflecting on these questions is essential to broaden our vision of the cosmos. In this context, relativity is not just a scientific theory. It is an invitation to explore the unknown. It pushes us to question our assumptions and to be curious about the truths that still elude us. The quest for answers about the Hubble tension is ultimately a pursuit of knowledge that connects us to the universe on a deeper level. Thus, as we analyze the Hubble tension through the lens of relativity, we realize that each discovery brings us one step closer to unraveling the secrets of the universe. As we move toward the future, the combination of theory and observation will remain fundamental to understanding the great cosmic puzzle in which we are immersed. Relativity, with its elegance and complexity, reminds us that the universe is a place full of mysteries, where each answer generates new questions. In the end, the Hubble tension not only challenges our understanding of the universe, it also inspires us to keep exploring, searching, and learning about our place in this vast and intriguing cosmos. In the vast universe of cosmology, the Hubble tension has sparked great interest and often confusion. What happens when the theories that have guided us for decades begin to falter? The Hubble tension is not just a number. It is a puzzle that tests our understanding of the laws of the cosmos. But is it possible that there are alternative theories that could explain this discrepancy in the measurements of the Hubble constant? One of the ideas that has gained traction in recent years is that of modified gravity. Unlike the traditional gravity we know, this theory suggests that the laws of gravity may not be the same throughout the universe, especially on very large scales. Imagine that instead of having a rigid and uniform ruler measuring gravity, we had a flexible tape measure that adapts to circumstances. What if in some parts of the universe, gravity acted differently? This concept could offer a new perspective on the expansion of the universe. Modified gravity not only seeks to resolve the Hubble tension, but also attempts to make sense of other anomalies observed in the cosmos. Some theories in this line, such as the TV's gravity theory, suggest that gravitational forces behave differently in the context of dark matter and dark energy. But how can we test these ideas? This is where observation becomes our best ally. At its core, science is based on observation and evidence. Alternative theories must undergo rigorous scrutiny. What data can support a modification of gravity? Cosmologists look to distant galaxies and the large-scale structures of the universe to search for patterns that may indicate whether gravity behaves differently. However, so far, observations have not provided a definitive answer. Another intriguing idea is the possibility that there are new particles or interactions that we have yet to detect. In this sense, some scientists propose that there could be unconventional interactions affecting the expansion of the universe. Imagine that in addition to the forces we know, there are hidden forces that could be playing a crucial role in the dynamics of the cosmos. But how do we detect what we cannot see? The answer is not easy, but it involves ongoing research efforts. Alternative theories are also challenged by the need to be consistent with what we already know. Modern physics has managed to explain numerous phenomena through relativity and the standard model of particles. So while the idea of modified gravity is fascinating, it must also fit into the larger puzzle of our current knowledge. This process of fitting the pieces together is what brings science to life. As scientists explore these alternative theories, they find themselves at a crossroads. On one hand, the Hubble tension pushes us to question our fundamental beliefs. On the other, the need for solid evidence makes it a delicate terrain. The scientific community must remain open to new ideas, but also skeptical of concepts that have not been validated. The exploration of alternative theories also raises philosophical questions. If the universe behaves differently than we think, what does that mean for our understanding of reality? We may not just be talking about numbers on a board. We are talking about our perception of the cosmos itself. Are we willing to accept that there is more to the universe than we can measure and observe? Meanwhile, the search for answers continues. New space missions and advanced telescopes are being developed to shed light on these questions. What discoveries does the future hold for us? Technology is advancing rapidly, and with it, our tools for exploring the universe are becoming more sophisticated. The Hubble tension has opened the door to a broader conversation about what we know and what we still ignore. Science is not a straight path. It is a journey full of unexpected twists and surprising discoveries. Alternative theories are part of this journey, offering new perspectives on old problems as we enter this new era of astronomy. Collaboration among scientists becomes essential. Cosmology is a field that thrives on the diversity of ideas and approaches. Each theory, each experiment contributes to a more complete understanding of the universe. Therefore, the Hubble tension is more than just a simple dilemma. It is an opportunity to join forces and rethink what we know. With each advance, we get a little closer to the truth, even if that truth may be more complex than we ever imagined. Science is in constant evolution, and with it, our understanding of the cosmos. The Hubble tension is just one part of a much larger puzzle, and solving it could lead us to discoveries that would change our understanding of the universe forever. So as we continue to explore, let us remember that every question is an open door to new possibilities. What do the stars tell us about the universe we live in? For several years, the Hubble tension has captured the attention of astronomers and cosmologists around the world. But what's new in this fascinating field of study? Recent observations have provided intriguing data that could offer answers to questions that have puzzled scientists. One of the most exciting areas of research comes from the study of supernovae. These stellar explosions act like beacons in the vast ocean of space, providing valuable information about the expansion of the universe. But what have these explosions revealed about the Hubble constant? By comparing supernova measurements from different epochs, scientists have noticed significant discrepancies. In simple terms, these explosions do not always seem to behave as expected, leading to more questions than answers. Another source of data is the cosmic microwave background. This remnant of the Big Bang serves as a snapshot of the universe's earliest moments. Recently, more precise measurements have suggested a faster expansion than some theories predict. But why is there this difference? This is where the Hubble tension becomes a puzzle, as these new data seem to contradict what was previously thought about the rate of cosmic expansion. The Hubble Space Telescope has been fundamental in this process. Observations made by this telescope have allowed scientists to measure distances and velocities with unprecedented detail. However, despite its success, measurements of the Hubble constant vary depending on the technique used. This leads us to wonder, why do different methods produce such diverse results? The answer may lie in the very nature of the stars and galaxies we observe. Some researchers have begun to explore the possibility that dark energy, that mysterious force that seems to accelerate the expansion of the universe, is influencing these measurements. But how could this be possible? Dark energy might be affecting the speed at which galaxies move, further complicating the understanding of the Hubble tension. If dark energy is changing over time, this could explain the discrepancies between different measurement techniques. Recent observations have also highlighted a series of new theoretical models. Some scientists are proposing adjustments to the laws of gravity that could help reconcile the differences in measurements. But do we really need to modify our existing theories, or is there an error in our observations? This is a crucial question that still lacks an answer. Additionally, research on Cepheids, those stars that twinkle predictably, has taken an unexpected turn. Recent studies suggest that there could be variations in their luminosity that we had not previously considered. This leads us to question whether the tools we have used so far to measure distances in the cosmos are really as accurate as we thought. Could it be that we have been measuring incorrectly? International collaborations are emerging to address these issues. Astronomers from around the world are working together to compare data and methods. which could lead to a greater understanding of the Hubble tension. This collective effort is crucial, as each new discovery can influence our understanding of the universe, but how long will it take to reach a consensus? New technologies are also being developed that could improve our measurements. More powerful telescopes and advanced data analysis techniques are on the horizon, promising to provide a much clearer view of the universe's expansion. But will these new tools be enough to resolve the Hubble tension, or will they simply open more doors to even more complex questions? The scientific community is aware that the Hubble tension is not just a technical problem. It is a challenge that could change our understanding of cosmology, and as we move forward in this exploration, the implications could be profound. If it is confirmed that the Hubble constant is different from what was thought, it could mean that our view of the universe is incomplete. It is fascinating to think about how this mystery is connecting scientists, philosophers, and science enthusiasts around the world. As we seek answers, we remember that each question brings us a little closer to understanding our place in the vast cosmos. The Hubble tension, far from being just a simple number, is a window into the mysteries of the universe and the complexities of its expansion. Thus, as we continue to observe the stars and gather data, the story of the Hubble tension continues to unfold. Each new discovery not only provides fragments of information but also raises new questions, challenging our understanding and stimulating the imagination. In this endless quest, science reminds us that the universe, in all its vastness, still has much to reveal. The Hubble tension is not only a puzzle for scientists, but it is also shaping our understanding of the universe in unexpected ways. What does this discrepancy in the measurements of the Hubble constant really mean? To understand it, it is helpful to think of the cosmos as a vast ocean in continuous expansion. Galaxies are like ships moving away from each other, and the speed at which they separate should be predictable. However, the measurements we have made show that some galaxies are moving away faster than we expected. This is not just a scientific curiosity, it challenges our current model of the universe. The implications of the Hubble tension are enormous. On one hand, if the measurements are correct and some galaxies are receding faster, that could mean our understanding of dark energy, which is believed to drive the expansion of the universe, is incomplete. It would be as if we were trying to solve a mystery without knowing all the details. What if dark energy, instead of being a constant force, had variable behavior? This uncertainty leads us to rethink our theories and cosmological models. On the other hand, this discrepancy could also be a sign that there are perhaps other factors at play, elements we have not yet considered. It could be that dark matter, that mysterious component of the universe we cannot see, is influencing the expansion in ways we have not managed to capture. This leads us to wonder, could the Hubble tension be a clue about new physics that we have yet to discover? Every time astronomers conduct new studies and observations, more questions than answers arise. How does this affect our understanding of time and space? The Hubble tension could be an indicator that the cosmos is more complex than we thought. Perhaps what we consider laws of physics are not so immutable, but can be adjusted as we advance in our knowledge. Speaking of laws of physics, the Hubble tension also leads us to reflect on our place in the universe. If our current theories cannot explain what we observe, that means we might be looking in the wrong direction. What does this tell us about our curiosity and our desire to understand the unknown? It is a reminder that science is a continuous process of exploration and discovery. As cosmologists work to resolve this tension, they are realizing that collaboration is key. Scientists around the world are joining forces, sharing data and theories to delve deeper into this mystery. Just like a team of detectives working together to solve a complicated case, the scientific community is discovering that the answers may be closer than they think, but require a collective effort to unravel them. However, Amidst this search for answers, a fundamental question arises. What if we never find a clear solution? Does that mean our theories and models are incorrect? Not necessarily. The history of science is full of examples where discrepancies have led to significant advancements. Perhaps the Hubble tension is simply another step in our evolution as scientists. Moreover, reflecting on the impact of the Hubble tension helps us understand that despite our desire for certainty, science often operates in ambiguity. This process of questioning and re-evaluation is essential for the advancement of knowledge. It is as if the universe is telling us that we must be open to new ideas and approaches. In this information age, it is crucial to communicate these concepts clearly and accessibly. The popularization of science becomes vital for the public to understand these complex phenomena. How can we make the Hubble tension and its implications more comprehensible to everyone? The answer may lie in storytelling, making science relatable and exciting. As we move into the future of cosmology, the Hubble tension could be the key that unlocks new horizons in our understanding of the universe. What discoveries await us? The possibility that resolving this enigma could transform our view of the cosmos is thrilling. It reminds us that while we are in search of answers, the journey itself is what truly enriches our understanding of the universe. Finally, in reflecting on the Hubble tension and its impact on cosmology, it is essential to remember that every answer we find generates new questions. This is the essence of science, an endless cycle of discovery. As we continue exploring, the Hubble tension invites us to keep an open mind and keep questioning what we think we know about the universe. Ultimately, this quest for knowledge not only brings us closer to scientific truth, but also connects us with our innate curiosity as human beings. What does the Hubble tension really mean for our understanding of the universe? This question takes us on a fascinating journey into the depths of cosmology and invites us to reflect on our place in a vast and enigmatic cosmos. The Hubble tension is not just a number, it is a window into the mysteries of the universe, an indication that there is more to discover and understand. When we talk about the Hubble tension, we are referring to an intriguing discrepancy. Different methods of measuring the expansion of the universe yield results that do not always agree. This raises a fundamental question. If the laws of physics are universal, why do we have this discrepancy? The answer could reveal much about the very nature of the cosmos. Are we facing a simple measurement error, or is there something deeper at play? Let's reflect for a moment. If the universe is expanding, what does this mean for our perception of time and space? Imagine you are on a balloon that is slowly inflating. As the balloon grows, the points drawn on its surface move away from each other. This phenomenon, which seems simple, has profound implications. The expansion of the universe suggests that, in a sense, time itself might be flowing differently in different parts of the cosmos. The Hubble tension pushes us to consider even deeper questions. Could there be aspects of the universe that we do not fully understand? Dark energy, for example, is a concept that has challenged our notions of gravity and matter. This mysterious force seems to be accelerating the expansion of the universe. But what is it really? Is it a property of space itself or something we have yet to discover? Thinking about dark energy leads us to question the nature of reality. If dark energy is present, does this mean there are more dimensions than we know? Some scientists suggest that we might be living in a universe with multiple dimensions, where the rules governing our existence are only a fraction of what reality truly is. How would this change our understanding of time and space? Moreover, the Hubble tension invites us to look back in time. When we observe the cosmic microwave background, what we are really seeing is an echo of the birth of the universe. This radiation provides us with a glimpse into the first moments after the Big Bang. If the Hubble tension is revealing that our current theories are insufficient, what new narratives might emerge from these observations? The philosophical implications of the Hubble tension are equally intriguing. If the universe is more complex than we assume, what does this mean for our existence? Are we alone in this vast cosmos, or are there other forms of life also trying to decipher their own mysteries? The quest for answers to these questions could change the way we view the world. In this context, the Hubble tension becomes a symbol of human curiosity. It drives us to keep investigating, to not settle for simple answers. Science advances when we dare to question what we know. Throughout history, every great breakthrough has emerged from the need to understand the unknown. At the same time, there is a community of scientists working tirelessly to resolve the Hubble tension. These cosmologists, astrophysicists, and mathematicians are joining forces, sharing data, and conducting experiments. Collaboration is essential to make progress in this field. Science is not a solitary endeavor. It is a continuous dialogue among curious minds. The Hubble tension also reminds us of the importance of effectively communicating science. In a world where information spreads rapidly, it is crucial for the public to understand these complex concepts. Science must be accessible to everyone, not just experts. How can we inspire the next generation of scientists? How can we make science a part of everyday conversation? Each new measurement and each new discovery are steps toward a deeper understanding. The Hubble tension, though perplexing, is also an opportunity. It offers us the chance to question, to explore new ideas, and to expand our boundaries of knowledge. In this sense, the future of cosmology is bright and full of possibilities. The Hubble tension, then, is not just a challenge for scientists. It is an invitation for each of us to be part of this exploration. It reminds us that the cosmos is a place full of mysteries, and our curiosity is the key to unraveling them. In every star and in every galaxy, there exists a story waiting to be told. The question is, are we ready to listen? As we continue our search for answers, it is vital to keep an open mind and an inquisitive spirit. Science is an endless journey, and the Hubble tension is just one of many stops along the way to understanding the universe. The adventure is just beginning. The search for answers about the Hubble tension is undoubtedly one of the most intriguing challenges in modern cosmology. We are faced with an enigma that tests not only our tools and methods of observation, but also the way we understand the universe itself. But what does this tension really mean? Why is it so important to resolve it? The answer may be deeper than it seems. When we talk about the Hubble tension, we refer to the discrepancy between different measurements of the Hubble constant, that key that tells us how fast the universe is expanding. Imagine trying to measure the speed of a car on a highway. If one group of people has a stopwatch and gets one result, while another group uses a different method and arrives at a different number, the first question that arises is, what is going on here? The answer to this question could open doors to a new understanding of the cosmos. Scientists are working hard to address this discrepancy, but how are they doing it? One approach is to use new technologies and observation techniques that allow them to obtain more precise data. For example, the Hubble Space Telescope, which has been an invaluable tool, continues to contribute to our understanding. But there is a limit to what even the best telescope can achieve. So, what more can be done? The key may lie in collaboration between different disciplines. Astronomers, physicists, and mathematicians are joining forces to solve this tension. Imagine a puzzle where each piece is crucial to completing the picture. Each researcher brings their own perspective, and together they are trying to fit the pieces of this complex cosmic puzzle. But can such a diverse collaboration really make a difference? Some researchers are exploring alternative theories that could offer answers. What if what we know about gravity needs to be revised? The idea that the laws of physics could change at cosmological scales is not as far-fetched as it seems. Instead of passively accepting the discrepancies, some scientists are considering that perhaps gravity behaves differently in the vast universe. Are we then on the brink of a radical change in our understanding of physics? Moreover, some are revisiting observations of the cosmic microwave background. This radiation, which is an echo of the Big Bang, is full of information about the initial conditions of the universe. Could it be that by studying this radiation more deeply, we find clues that lead us to resolve the Hubble tension? It's like searching for hidden treasure in the history of the universe, and each new finding could be a key to opening a new door. However, the search for answers is not an easy path. There are obstacles at every corner, measurements are complicated, and data can be misleading. For example, if a new method is found that seems to yield promising results, it is essential to subject it to scrutiny. Science advances through trial and error, and each mistake is a valuable lesson. But what if the mistakes are the key to discovering something completely new? In this quest, communication plays a fundamental role. Scientists must share their findings and discuss their theories, but it is also crucial that the general public understands the importance of these issues. How can we make science accessible and exciting? The answer may lie in storytelling. Just like a captivating novel, science can draw people in and keep them engaged as they unravel the mysteries of the universe. The Hubble tension also invites us to reflect on our own existence. If the universe is expanding and what we think we know is in question, what does that mean for us? Each discovery can change our perspective on our place in the cosmos. Perhaps instead of seeing ourselves as isolated beings on a planet, we should consider ourselves part of an unimaginable vastness that continues to evolve. As we continue to investigate and explore, it is important to remember that knowledge is a journey, not a destination. Every answer we find opens up new questions. The Hubble tension is just one of the many questions that science faces, and each one brings us a step closer to unraveling the secrets of the universe. Finally, the search for answers about the Hubble tension is not just an intellectual exercise, it is a reminder that we are curious by nature. Every time we look at the starry sky, we wonder what lies beyond. Science provides us with the tools to explore those questions, and although the path may be uncertain, the adventure of discovery is what truly gives meaning to our existence. So as we continue this exciting search, let us remember that each question can be the beginning of a new chapter in the story of humanity. The Hubble tension is just one of the many stories that await us, and each discovery brings us a little closer to understanding not only the universe but also ourselves. The scientific community is in a constant ebb and flow of ideas, theories, and debates, all aimed at better understanding the universe we live in. The Hubble tension, a phenomenon that has captured the attention of numerous cosmologists, has become the center of many of these discussions. But how are scientists collaborating to tackle this enigma? What role do conferences and forums play in this process? To begin with, it is fascinating to think about how cosmologists around the world share their findings and theories. Imagine a large puzzle of the cosmos, where each researcher has a different piece. By putting these pieces together, the scientific community can gain a more complete view of the universe. In this sense, workshops and conferences become vital spaces for scientists to discuss their discoveries, pose questions, and of course, listen to other experts. One of the most intriguing aspects of scientific collaboration is how researchers can arrive at different conclusions using similar tools. Sometimes they find themselves in disagreement about the best way to interpret the data. How are these differences resolved? The answer lies in open dialogue and mutual respect. It is like a friendly debate in a game of chess, where each player has their strategy, but all seek to reach the same conclusion. On the other hand, social media and digital platforms have transformed the way scientists communicate. There is no longer a need to wait for an in-person conference to exchange ideas. Now, a researcher in one part of the world can share their findings online and receive feedback from colleagues in real time. Can you imagine the speed at which ideas spread? This accelerated exchange can be both a blessing and a challenge. as information must be verified and contextualized. Teamwork is not limited to cosmologists alone. Astronomers, physicists, and mathematicians from different disciplines are joining forces to address the Hubble tension. The question that arises is, how does each field benefit from these collaborations? Each discipline brings its own set of tools and unique perspectives. For example, while astronomers focus on observing galaxies, theoretical physicists provide models that could explain why measurements of the Hubble constant vary. Thus, interdisciplinary exchange becomes a driving force for the advancement of knowledge. However, not everything is smooth sailing. Sometimes differences of opinion can lead to tensions within the scientific community. But this is where the true essence of science comes in: curiosity and the desire to uncover the truth. When a group of scientists faces a disagreement, it is this drive to understand that leads them to delve deeper into research. Isn't it fascinating how controversy can be a catalyst for the advancement of knowledge? In this context, young researchers also play a crucial role. Their energy, enthusiasm, and fresh ideas can bring new perspectives to old problems. What if the solutions to the Hubble tension are hidden in the minds of the next generation of scientists? Universities and research centers are fostering this collaborative spirit, creating spaces where students can work alongside established experts in the field. Scientific publications are another essential avenue for researchers to share their findings. Each article is a brick in the building of universal knowledge. However, peer review is a critical process that ensures only quality work reaches the public. Have you ever wondered how many articles are published annually on cosmology? The number is staggering, underscoring the importance of collaboration. Moreover, the pressure to publish can lead some scientists to seek quick solutions. But the community as a whole has a self-regulating mechanism. As more and more researchers review and critique each other's work, the quality of research tends to improve. It is an invaluable feedback cycle that ensures theories undergo rigorous scrutiny before being accepted. The role of scientific organizations is also fundamental. These institutions not only fund research but also facilitate meetings and collaborations among scientists from various disciplines. What impact does this have on the quest for answers to the Hubble tension? By providing a platform for dialogue and the exchange of ideas, these organizations help create an ecosystem where innovation can flourish. In this journey of discovery, collaboration networks extend beyond national borders. Scientists from different countries are working together, sharing data and resources. As science becomes a truly global endeavor, the question also arises: what challenges do they face when working in an international context? Cultural and linguistic differences can be barriers, but the passion for knowledge is a universal language that unites researchers. Finally, there is something very powerful about the scientific community: its resilience. Despite challenges and discrepancies, scientists continue their quest for answers. The Hubble tension is just one example of how a mystery can unite brilliant minds in a joint effort. Could it be that in this search for truth, we are closer to understanding not only the cosmos, but also our own humanity? Undoubtedly, the answer to that question may be as fascinating as the universe itself. Science is a vast ocean of knowledge, and often we find ourselves on the shore, fascinated by the waves of discoveries that come our way. One of those phenomena that has captured the attention of many is Hubble's tension. But why is it so crucial to communicate these discoveries to the general public? The answer lies in human curiosity. When people understand scientific concepts, they feel more connected to the universe and its workings. At its core, science is not just a set of formulas and data, but a constantly evolving story. It is a narrative that involves us all. Therefore, making complex topics like Hubble's tension accessible can transform not only our perception of the cosmos, but also our own existence. Imagine for a moment that each star in the sky is a point of light in a vast story of exploration. If we can spark interest in more people, perhaps they will be inspired to become the future scientists who will solve the mysteries of the universe. To achieve this, the way we communicate is fundamental. Using simple analogies can be the bridge that connects scientific knowledge with everyday understanding. For example, when talking about the expansion of the universe, we can compare it to an inflating balloon. As the balloon expands, the points drawn on its surface move away from each other. This simple image can help many visualize how galaxies are moving apart in our vast cosmos. The use of stories is another powerful tool. Telling the story of Edwin Hubble and his discovery of the expansion of the universe can be like narrating an epic adventure. Hubble, with his telescope, peered into a world of wonders and revealed that the universe is not static but is in constant motion. By presenting science as a series of exciting tales, we capture people's attention and lead them to want to know more. Emotion also plays a crucial role. When discussing Hubble's tension, we can pose intriguing questions. What if our laws of physics are not enough to explain the universe? What mysteries await us in the depths of space and time? These questions not only spark curiosity, but also invite reflection on our place in the cosmos. Data visualization is also essential. Imagine graphs and tables that, instead of being just cold numbers, become visual stories. A graph showing how measurements of the Hubble constant have changed over time can be compared to a map revealing a path full of surprises and detours. When people can see and understand these changes, they feel more connected to the scientific process. But what about the role of the scientific community? Collaboration among scientists from various disciplines is fundamental. When cosmologists debate and share their findings, they are building a network of knowledge that benefits everyone. For the public, this means that science is not a solitary endeavor, but a team effort aimed at unraveling the secrets of the universe. The idea that many brilliant minds are collaborating could inspire others to join this quest. Moreover, modern technology has revolutionized the way we communicate science. Platforms like social media and YouTube channels allow ideas to reach broader audiences. Scientists can explain complex concepts in an engaging and accessible way using videos, infographics, and animations. This visual approach not only makes science more appealing but also more understandable. The popularization of science also faces challenges. Sometimes the complexity of certain topics can lead to confusion. Therefore, it is essential for science communicators to be clear and concise. Using simple language and avoiding technical jargon can help more people feel included in the scientific conversation. Science should not be an exclusive club, but an open space for all. Education plays a crucial role in this process. From elementary school to higher education, cultivating a culture of curiosity and critical thinking is fundamental. Students should be encouraged to ask questions and explore the world around them. An inquisitive mind is the first step toward forming future scientists and communicators who will continue the tradition of exploring the cosmos. Ultimately, the popularization of science has a profound impact on society. By fostering understanding of Hubble's tension and other scientific concepts, we are not only educating people but also empowering them. Science has the potential to inspire positive changes in the world, from informed public policies to greater awareness of our place in the universe. The relationship between science and society is dynamic and complex. As more people engage with and understand science, a virtuous circle is created. Curiosity leads to more questions, and the answers to those questions drive new discoveries. Thus, Hubble's tension becomes a catalyst not only for understanding the cosmos, but also for uniting people in a shared quest for knowledge. Science is a journey, and each of us has a role to play. By sharing and communicating science effectively, we contribute to a legacy that transcends generations. Hubble's tension, with all its mystery and potential, invites us all to be part of this wonderful adventure. Are you ready to explore? Have you ever wondered what the future of cosmology will be like? The answer to this question could change our understanding of the universe and the way we see ourselves. The Hubble tension, that discrepancy in the measurements of the Hubble constant, is at the center of a huge scientific debate that not only has technical implications, but also invites us to reflect on our existence and the cosmos around us. Imagine the universe as a vast ocean in which we navigate. Each star and galaxy is like scattered islands in that immensity. With each new measurement, cosmologists try to chart a more accurate map of this ocean. But what happens when the islands do not align as they should? The Hubble tension is like a map that shows islands in positions different from what was expected. This leads us to question not only our measuring instruments, but also the fundamental laws that govern the universe. Looking to the future, technological advances promise to open new doors in the exploration of the cosmos. Next-generation telescopes on Earth and in space are on the way, and their ability to observe the universe in wavelengths we have never explored before could reveal hidden secrets. Who knows what amazing discoveries await us? Perhaps these new telescopes will help us find an answer to the Hubble tension. Moreover, international collaborations in scientific research are on the rise. Imagine scientists from around the world joining forces, sharing data and theories in a collective effort. This collaborative approach not only accelerates progress in resolving the Hubble tension, but also fosters a sense of community within the scientific community. What impact will these collaborations have on our theories about the expansion of the universe? Artificial intelligence also comes into play. How could machine learning algorithms help us analyze astronomical data more efficiently? With the enormous amount of information we are collecting, artificial intelligence has the potential to identify patterns that humans might overlook. This could be crucial for better understanding the Hubble tension and, ultimately, for giving us clues about the nature of the universe. Thinking about the future of cosmology leads us to question fundamental physics. As more data accumulates, we might see that our current theories need adjustments. Are we ready for a revolution in our understanding of how the cosmos works? The Hubble tension could be the catalyst that pushes us toward new theories that challenge our deeply held beliefs. The search for answers also raises philosophical questions. What does it mean for us as human beings to understand that there is still more to discover? The Hubble tension is not just a scientific problem, it is also a reminder of our innate curiosity and our desire to understand the universe. In a sense, every answer we find generates new questions, keeping the spark of discovery alive. As the field of cosmology advances, it is important that science is accessible to everyone. The popularization of science plays a crucial role in how we understand and relate to these complex concepts. How can we make the Hubble tension and its implications understandable and exciting for the general public? Effective communication can inspire the next generation of scientists and thinkers. New theories emerging, such as those suggesting modifications to gravity, offer intriguing perspectives. Could it be that we are on the verge of rewriting what we know about gravity and its relationship to the expansion of the universe? The Hubble tension not only tests our current theories, but also leads us to consider alternatives that could change the game. Over time, as we continue to collect data and adjust our theories, changes in our understanding of the universe are likely to occur. Predictions about what cosmology will look like in the future are exciting. What if we discover that the universe is even stranger and more wonderful than we imagined? The Hubble tension could be just the tip of the iceberg in a vast ocean of discoveries to come. Science is a continuous journey of exploration, and the future of cosmology promises to be full of surprises. Each discovery brings us a little closer to unveiling the mysteries of the universe. Are we ready for what is to come? Resolving the Hubble tension could be a milestone in our history, marking a shift in how we understand our place in the cosmos. So, as we look toward the horizon of cosmology, let us remember that each question leads us to new adventures. The Hubble tension is just a part of a larger puzzle, one that challenges us to keep seeking answers. Curiosity is the engine of our desire to know, and the future awaits us with open arms. What exciting discoveries does the universe have in store for us? The answer lies beyond the stars, waiting to be uncovered. The Hubble tension, that enigma in the vast universe, invites us to reflect on our understanding of the cosmos. Why are there differences in the measurements of the Hubble constant? This question is not only intriguing, it is fundamental to unraveling the secrets of the universe. In this journey of exploration, we have traveled a path filled with discoveries, theories, and passionate debates that are redefining what we know about the expansion of the universe. The Hubble constant, in essence, tells us about the speed at which galaxies are moving away from us. But what does this really mean? Imagine the universe as a balloon, with each galaxy as a point on the surface of the balloon. As you inflate the balloon, those points move away from each other. Thus, the Hubble constant gives us a measure of how fast those galaxies are receding as the universe expands. However, the fact that different methods yield different answers is like some points moving away faster than others when inflating the balloon. Why does this happen? As we explore the measurements of the Hubble constant, we find a variety of techniques, each with its advantages and disadvantages, from the use of supernovae to the parallax of Cepheids. Each method brings its own set of challenges. While some scientists have reached conclusions suggesting that the universe is expanding at an accelerated rate, others have found more conservative results. What does this tell us about our understanding of the cosmos? The answer may be more complex than it seems. Dark energy, that mysterious component that makes up more than 70% of the universe, plays a crucial role in this story. Imagine the universe as a constantly flowing river. Dark energy would be like a current pushing the water, accelerating its flow. However, when trying to measure the speed of the water, different sections of the river may show different speeds. This translates into the discrepancies we observe in the measurements of the Hubble constant. The cosmological models we have developed are like maps attempting to guide us through this vast ocean of stars and galaxies. However, as new evidence emerges, those maps may need to be updated. The Hubble tension challenges us to revisit our current theories and consider that there may be something more that we have yet to discover. Are we on the brink of a new revolution in cosmology? The impact of dark matter cannot be underestimated. This form of matter, which we cannot see but know is there due to its gravitational influence, acts as an invisible agent affecting the dynamics of the universe. Could it be that the Hubble tension is related to how dark matter interacts with dark energy? The answer could open the doors to a new understanding of the forces that govern our universe. As we move into the era of modern astronomy, technological advancements have transformed the way we observe the universe. More powerful telescopes and sophisticated analysis techniques have allowed us to obtain more precise data. However, with each new discovery, new questions also arise. Are we really closer to resolving the Hubble tension, or have we simply opened new doors to an even more complex labyrinth? Recent observations have provided us with a fascinating glimpse into the dynamics of the universe, but they have also raised more questions than answers. The Hubble tension not only challenges scientists, but also invites the scientific community to collaborate and debate. Science advances through dialogue and discussion, and the Hubble tension has become a focal point for many cosmologists. In this context, the popularization of science plays a fundamental role. Communicating these complex concepts clearly and accessibly is crucial for the public to understand not only the Hubble tension but also its relevance in our everyday lives. After all, every time we look up at the sky, we are observing a constantly changing universe full of mysteries to solve. The future of cosmology is full of possibilities as we continue to investigate we may find answers that not only clarify the Hubble tension, but also transform our understanding of fundamental physics. The quest for answers is an adventure that drives us to keep exploring, to keep questioning, and above all, to keep learning. The Hubble tension is not just a scientific challenge, it is also an invitation to reflect on our existence and our place in the universe. It reminds us that despite our advances, there is still much to discover. Science is a journey, and each discovery brings us a little closer to unveiling the secrets of the cosmos. So, the next time you look at the stars, remember, each bright point in the sky is a galaxy telling us a story that we are still learning to understand. Ultimately, the Hubble tension is a reminder that the universe is a place full of mysteries, and every answer we find leads us to new questions. Human curiosity is infinite, and as long as we continue to seek answers, the cosmos will remain an open book, waiting to be read. At the end of the day, what truly matters is the journey itself, the pursuit of truth, and the connection we feel with the vast universe that surrounds us.